Hello everyone. In this video, we will try to learn about doping in semiconductors. So if you take any semiconductor, like for example, the silicon atom, it has 4 valency electrons. So it can make a covalent bond with other silicon atom and it can form a semiconductor. So this is intrinsic semiconductor. Intrinsic semiconductor. So for example, if you dope a pentavalent material like phosphorus, it has 5 valency electrons. So silicon has 4 valency electrons. So there are 4 silicon atoms that can make covalent bond with phosphorus. I mean, like the 4 valency electrons of this phosphorus can make a covalent bond with the silicon atom. So it has a free electron which is not bound to any kind of other atoms within this semiconductor. I mean, like it is a free electron, it can move into the semiconductor crystal. If you take the band structure of this phosphorus doped semiconductor, so this is the conduction band and this is the valence band. So if these dopants are sufficient enough to form a dopant level in between the conduction band, and because of this extra free electrons which is closer to the conduction band, so this dopant band is very much closer to the conduction band because this free electron is loosely bound to the phosphorus atom, so it can free from this atom and can form the phosphorus ions. So these electrons from this dopant level can move to conduction band if there is any temperature change in the semiconductor. So these electrons are populated in the conduction band and that contribute to the conductivity. So in this way, the free electrons can move from the dopant level to conduction band and that can contribute to the conductivity. So this type of semiconductors called N-type semiconductor. The majority charge carriers are electrons in this semiconductor. For suppose if you do boron atom to the silicon semiconductor, it has only 3 valence electrons. So these 3 electrons are covalently bound to the silicon atom, and there is a missing of electrons in the boron atom and silicon bonding. So this missing of electron is called hole. So if you see the band structure of this type of semiconductor, this is the valence band and this is the conduction band. So because of this missing electrons in this boron atom, so there is a dopant level, energy level near the valence band. So if suppose there is a small temperature change in the semiconductor, the electrons from the valence band can jump into the dopant level. So the boron atoms are ionized by jumping the electrons from the valence band to the dopant level. So here again the holes are created in the valence band. So there is electron transport within the valence band. So this hole can move down and the electrons can move up. So in this way, the conductivity takes place in this semiconductor. So this type of semiconductor called p-type semiconductor. So the majority carriers are holes in this semiconductor. Majority carriers are holes. In case of n-type semiconductor, the majority carriers are electrons. So it is very important to understand this n-type and p-type semiconductor, because if you see any kind of a diodes like PN junction diodes or bipolar junction transistors, so these semiconductors, n-type and p-type semiconductor, mainly play a big role in understanding those kind of devices. So in this way, you can easily understand the n-type and p-type dopant in semiconductors. I hope this will give you some brief understanding on doping and conductivity in n-type and p-type semiconductors.